Hello, I am Mr. an information and communication consultant. I hope that by sharing information and communication knowledge with you, we can have a happy time together and that it will be beneficial for you. This time, I have brought data on the analysis of the state of wired and wireless communication services. Among wireless internet services, the average download speed of LTE service was found to be 120 megabits per second, while the upload speed was 41.83 megabits per second. Compared to the previous year, the upload speed showed a significant increase, from 26.84 megabits per second to 41.83 megabits per second. The Korea Information Society Agency recently published a report evaluating the quality of communication services containing such information. This report provides various information about the quality of communication services to help users make informed choices about products. According to the report, Gigabit Internet was found to have a download speed of 895.7 megabits per second and an upload speed of 916.08 megabits per second, achieving nearly 10 times the speed of high-speed internet and rapidly encroaching on the wired internet market. The quality assessment of communication services is conducted annually in accordance with Article 56, Paragraph 2 of the Telecommunications Business Act, and it has the effect of encouraging operators to expand their investments in areas with poor quality, such as underdeveloped regions, islands, mountainous areas, and maritime routes. In particular, the quality assessment of communication has expanded the number of vulnerable areas expected to have poor quality from 50 to 78 compared to the previous year, and it has newly introduced the quality assessment of public Wi-Fi services alongside the existing quality assessment of commercial Wi-Fi services provided by current telecommunications operators. Next, we will measure the internet speed on a site called BenchBee. Please search for BenchBee on Naver. Select the item for measuring internet speed. Enter your region, fill in the information, and then click Confirm. Once you press Start Measurement, you will see that the internet speed measurement is in progress. So our home has an upload speed of 86.3 megabits per second, which is a decent speed. It would be good for you to measure the internet speed in your area like this. The wireless internet provided by communication service providers is mainly divided into LTE and Wi-Fi. LTE was launched as a service, providing 75 megabits per second download and 37.5 megabits per second speeds in its early days. However, the demand for mobile data has been increasing, leading to a need for higher quality communication. The solution proposed by telecom companies is frequency aggregation. CA technology can combine two or more narrowband frequencies to create a single wideband frequency, achieving speeds of over 100 megabits per second, comparable to wired internet. Domestic telecommunications companies commercialized broadband LTEA services starting in the second half of 2014. This service combines a 10 MHz narrowband frequency with a 20 MHz wideband frequency using CA technology, delivering a maximum download speed of 225 megabits per second. In 2015, 3-band LTE service was launched. It combines one frequency providing broadband LTE service with two general frequencies to achieve a maximum speed of 300 megabits per second. In addition to frequency expansion, LTE service is further increasing speed through modulation techniques like QAM and multi-antenna technology like MIMO. Telecommunications companies are expected to realize 1 gigabit per second mobile communication soon by increasing frequency holdings and commercializing 256 QAM and 4x4 MIMO technology. The use of Wi-Fi is steadily increasing. The IEEE 802.11n standard, which currently supports speeds of up to 150 megabits per second, has become widespread, and it has reached speeds of up to 600 megabits per second using MIMO technology. Next, it shows an overview of high-speed internet service technology. The types include XDSL, LAN, HFC, and FTTH. XDSL refers to digital subscriber lines that enable high-speed data communication using telephone lines, while LAN refers to a network that connects multiple PCs and OA devices within a certain area, using high-speed communication lines to facilitate communication between devices. HFC refers to a network that uses both fiber optic cables and coaxial cables. FTTH means connecting fiber optic cables all the way to the home. Wired internet is broadly classified into gigabit internet and high-speed internet. Gigabit internet has been provided by the three major telecom companies since 2014. According to the government's plan to establish gigabit internet services, over 90% coverage was achieved in 85 cities and provinces nationwide by the end of last year. By utilizing broadband subscriber network technologies such as fiber optic subscriber networks, hybrid fiber coaxial networks, and local area networks, we provide transmission speeds exceeding 100 megabits per second, up to a maximum of 1 gigabit per second. In addition to the three major telecommunications companies, T-Broad, C&M, and CJ Hello Vision have also commercialized gigabit services. High-speed internet refers to internet services with speeds of 2 megabits per second or higher, and it has already stabilized with a large number of subscribers. Since 2015, the number of subscribers has surpassed 20 million, and the number of FTTH subscribers has approached that of LAN subscribers. In 2016, the spread of gigabit internet led to an increase in subscribers for LAN and FTTH services, while the number of XDSL and HFC subscribers showed a slight decrease. The boundary between mobile communication and Wi-Fi has disappeared, leading to a revised LTE quality assessment system that prioritizes consumer perceived quality over the previously measured LTE quality for each service, such as LTE-A, broadband LTE, and 3-band LTE-A. The integrated LTE measurement results showed a download speed of 120.09 megabits per second and an upload speed of 41.83 megabits per second. Compared to the previous year, the upload speed showed a significant increase from 26.84 megabits per second to 41.83 megabits per second, which is attributed to the application of carrier aggregation (CA) technology that combines frequencies to increase upload transmission speeds, an LTE download speed of 120.09 Mbps is more than twice as fast as Canada, which is rated as having the best quality overseas. In the case of Wi-Fi, the rapid expansion of the carrier-led GigaWi-Fi business has resulted in an average download speed of 144.73 Mbps and an upload speed of 141.47 megabits per second, representing significant quality improvements of 58% and 66% compared to the previous year. In particular, at subway stations, the active replacement of gigabit APs has led to a significant increase in Wi-Fi download speeds, reaching 270.4 megabits per second, up from 66.87 megabits per second the previous year. On the other hand, the Wi-Fi in subway cars still uses the Wibro network, showing an average download speed of 5.44 megabits per second and an upload speed of 4.71 megabits per second, indicating that the internet quality in the cars urgently needs improvement. The public Wi-Fi service, which began measuring in 2016, showed an average download speed of 115.98 Mbps and an upload speed of 113.76 megabits per second. As a result, it has been determined that both mobile communication and Wi-Fi have exceeded the benchmark speed of 100 MBPs for high-speed internet. Not only do we hardly feel any inconvenience while surfing the internet, but we have also reached a level where we can use real-time video streaming services with minimal delay. Additionally, a re-evaluation of areas that had a transmission success rate of less than 90% in last year's quality assessment showed an improvement rate of about 82%, indicating that the communication environment in vulnerable areas is also rapidly improving. If many viewers have questions about internet speed, it would be advisable to use the benchmarking tool I introduced to measure your internet speed. In this session, I shared materials on the analysis of the current state of wired and wireless communication services. I hope it was helpful to you. Thank you. Have a day.